Hello and welcome to my channel. Today I'm going to show you a way to generate data for your web or database application. Sometimes when you create an application you want to populate your database with some data, and if you try to do it manually it will take you a lot of time and it's a tedious work and it's not exactly something you want to do. So in this case you'd either program your own library that will handle this, or you will use a library that is already being created for you. And in this case we are going to use a library that is called Faker.js, and it exists on npm, and it's when you enter Faker into the npm search you will get the first one. The first one is the match, and we will be storing the data inside Postgres. Postgres is currently my favorite database, so we are going to use the PG connector to that. I have already created an application for you, so I'm not going to type that in. I'm going just to show you the steps that I have used to construct the application. And I'm not going to install an instance of Postgres on my computer directly. I'm going to use Docker. And if you haven't been using Docker, I highly recommend that you do, because in this case you can create multiple containers, and each container can contain an instance of your database or another application or whatever you want. And you can after that deploy that container into other machines without making any changes, which is great if you want to make your workflow effective. So here I have executed a Docker command that created an instance of Postgres on my computer directly. So I've used sudo, as Docker isn't allowed to use root privileges. So that's for security reasons. It's better to do it this way. It's better to access Docker inside through the sudo command. So I'm creating a container using the command run. I'm exposing the port 16,000 to the outer world outside of the container, and P means port, while I'm using the default Postgres port, which is 5432 inside the container itself. I'm making the process detached, and I'm naming my container my Postgres. And after that I'm specifying environment variables for Postgres itself. For example, Postgres password. So when you connect to the container, to Postgres inside the container, you will use this password, whatever you want, but I have chosen testing123. I have specified a Postgres user, which is usually the Postgres user. And I have specified another environment variable, which is PostgresDB, the database that you are going to connect to, which is in our case testingDB. And here is another very important thing to do, and that is allocating a volume to your container. If you allocate a volume to your container, to your database container, then your data will be persisted, which means when your container goes down or when you delete that container, your data will still be available to you for further use. So I'm allocating a volume called PG data, and the path to that volume is var live Postgres and a directory called data. Now this container will be spawned based on the Postgres image, and that's an official image that exists on Docker Hub. So this is the most recent instance of Postgres. We are going to be using that. After you execute this command, Docker will generate an ID for your container, but since we have created a name for that container, then your container will be using that name. So the container that we are going to be using is my Postgres. Now the container is now already running, and you can connect to your container using any front-end tool. In this case I'm using PGAdmin Since I'm on Linux, so I'm using PGAdmin 3. If you are on Mac or Windows, then there is already a newer version called PGAdmin 4, which is more modern and it contains more features. But I like to work on in Linux, so I will be sticking to that. So we will be. Let me show you first. I have created a table called users, and I'm going to show you that it has already a lot of data there. It has actually about 1,000 rows, and those are all already automatically generated using the program that I have written. So the table contains a user field, contains a field or column called user ID, and that's of type text, and that will generate a UUID for you, unique ID. And other than that, it has a first name, last name, email, phone number, and job title. And these are all functions that can be used from the Faker.js library. I'm going to delete those rows. Okay, and I'm going to show you that there is no data after that. Okay, so I have an empty table, and now I can show you the application itself. The application is very simple. First, you create a dbconfig of type JSON. You create a JSON file that contains the configuration for the connector to the database. And that JSON contains a user, a password, a DB name, which is testing DB, a host, which is the local host, and the port, which is the external port that we have specified. So if you take a look back, we have specified that we are going to expose the port 16,000 to the outer world. Okay, so I have included, using npm install, I have included the Faker library and the PG connector, the Postgres connector to the database. You know how to do that. First, you create an application using np-init, and you do yes for all the questions. That will generate a package.json file for you. And after that, you do npm install Faker. You enter that command. That will install the Faker library. And after that, you can add the PG connector, and that will install the PG connector to the database. And that's it. Then you create a file which is called app.js, and that will contain your application. You require the Faker.js library by writing const Faker, and require Faker. Then you require a pull constructor from the PG connector. You can also require a client, but there is no need for that in this application. You also require your JSON file, and you put it in a variable called config or whatever you want, but make it, I like to name it config for clarity. Now you create a new pool using the constructor that you have imported from the PG connector, and you specify the parameters from the config object that you have received. So you specify the user. From the config user, you specify the host, the database name, and the password that you have created, and the port. So there is nothing to that. Then you specify the level of randomness that you require from the Faker library. I've seen examples where they were using like 1, 2, 3 or something very simple. And in our case, I just wanted to make it a bit more random, so I've included a bigger number. You can try that. You can test and play with that the way you want. Next, I have created an empty array of people, an empty array of objects that I'm going to insert into this array. And here is the interesting part. I create a loop that is going to repeat itself for 1,000 times. You can test it for 10 times, for example, 50 times, and after that you can increase the number the way you like. And I'm creating a UUID, a unique ID, which is in the random namespace from Faker. And I'm creating a first name, which is created from the namespace using the function called, obviously, first name. A similar function is called last name. And then I'm populating the current object with the data that I have received. For example, I have an email, which is using a function from the internet namespace called email, and it receives a first name and last name, or an empty string if you want, but it's better to enter the data that you have generated so it looks more authentic. I'm generating also a phone number, which is in the phone namespace, and it uses a function called phone number. And of course, I'm generating a job title, which is coming from the namespace using a function called job title. After that, I'm pushing the object that I have created into the people's array. I have created a function called prepared statement, and that function will receive a data parameter, and that data parameter is the people that we have created. So I'm going to create a statement, a query statement in SQL in a text format, and in this case it's insert into users, and I'm going to insert the data into the relevant columns. In that case, these are the user ID, first name, last name, email, phone number, job title, and here comes the values. So I'm going to create a tuple. A tuple will be getting its components from the object that we have used to populate the people's array. And I'm going to call the object row in this case. And the tuple itself is called values. It's now empty, and the object row is also empty. So I'm going to loop to the length of the people's array, except for the last one, because there is a comma that I'm going to not add for the last instance. So I'm going here, I'm getting the first row or the row from the data from the people's array. I'm populating the first name and the last name and the job title. I have done something here. I'm replacing a single apostrophes here with double apostrophes because that will prevent SQL injections. If the Faker library generated names in the Irish format, for example, like O'Connor or Rayleigh, then that family name will be using an apostrophe. And in that case, SQL will reject that name, and it will understand only partially that name. For example, if you write O'Connor, for example, like this, okay, then SQL will see only this, like this, because all parameters in the text format will be inside apostrophes, and SQL will not understand that. So we need to do this. We need to enter two apostrophes and enclose the whole string with another apostrophe. In that case, that will pass. So after that, I'm creating the tuple itself. I'm inserting the parentheses here. I'm escaping the apostrophe, as you can see. I'm escaping the apostrophe at the start and at the end of each component. So I'm adding the user ID, the first name, the last name, the email, the phone number, the job title, and after that I'm closing the parentheses. After that I'm adding a comma, and I'm adding the tuple that I have added to the overall string of values. And here I come to the last row, and I'm doing just the same that I have done here, except that instead of adding a final comma here, I'm not adding that. I'm just adding a semicolon. And that's it. I'm returning an object that contains the statement itself and the values. I'm calling that prepared statement function. I'm entering the people's array as a parameter, which is called data inside the function itself. So, and after that, I'm receiving an object, and that object contains this, And after that, I'm doing a simple log here just for clarity, just to show you what's happening to the console. And now I'm using the pool, and I'm trying to connect to the database. If everything goes wrong, if something goes wrong, then I'm going to catch an error, and I'm going to show the error on the screen. I'm going to show it on the console. If everything goes okay and the pool connects, then it will return me a promise, and that promise will return me also a client, and that client will be executing the query that I have prepared. And that's it. Again, if everything goes well, that's it. You will have your data in the database. Otherwise, the catch clause will be catching the error and displaying it on the screen. So there is nothing more to that. So I'm going to show you now how is this going to look. So the application goes and generates a lot of data. Well, actually 1,000 rows. It will tell you that the program is connected to the database, and that's it. That's all to do it. Now I'm going to the SQL tool, and I'm going to show you what I have done here. Here you go. So you have now the data that you have generated inside your database, and you can do whatever you want now with this data. For example, if you have a web application, you can create let's say I don't know, user cards that you will show, or something else. For example, if you have an application of social media, you can create users using this way. So that's it. This concludes the tutorial, and I hope you have enjoyed that. Please leave any comments or suggestions. Please like, subscribe, and thank you, and see you next time.